Hello, everyone. I can see more people coming, but let's start. So my name is Nikos. I'm happy to be here in Thessaloniki, in the place where I studied 3 years ago, until actually 3 years ago. And the topic for today, so it's the last presentation, as Patroklos said, one of the last presentations for today. I'll try to make it as interesting as possible. I'll do my best. And if anyone survives until the end of the presentation, I have a bunch of vouchers here from my company. So the topic for today is all about source code searching, and in specific, how you can improve your team's source code searching capabilities. But before diving into the topic, the boring part, I studied first here in Thessaloniki I studied electrical and computer engineering here, then moved to the sunny Edinburgh for a master in computer science. And I started working for Hotels.com, which is part of Expedia Group, 2 years and 2 months ago. Initially, I was part of that team, which is responsible for the user authentication flows and the identification flows of the website. And recently, actually 2 weeks ago, I moved to a different team with slightly different responsibilities, since we are helping teams move to the cloud. And mainly, we are exploring and evaluating new technologies like the ones we had a bunch of presentations here about Istio and Service Mesh and Kubernetes and so on. My interest lies mainly in the area of source code mining and searching. And with my supervisors from the 2 universities that I studied, we have developed 2 systems. The one is Mandisa, and the other one is CLAMS, which we have published and presented in academic conferences. Those 2 tools or frameworks can help you when searching for code or when searching and mining API usage examples like CLAMS. The presentation for today is structured as follows. The first and main part is going to be around source code searching and search engines. So why you need a dedicated tool for that. We will go through an overview and a comparison between the most popular solutions in the market right now. Probably most of you don't know anything about this topic. So I think it's going to be interesting to see your reactions. And then because the decision on which service to use heavily depends on your needs and your team's or company's needs, we'll go through recommendations and things you need to consider. After that, we go through recent advances from big players like GitHub, Microsoft, or Google, because those companies are investing a lot. And they show us that this is a trendy topic. We're going to hear a lot about that in the next years. The second and minor part, as part of the second part, we're going to introduce a tool we have developed internally at Hotels.com, which builds on top of CLAMS, the system that I mentioned before, that we implemented at University of Edinburgh. But that is going to be only a minor part of the presentation, so let's start with the main one. Searching for source code and source code search engines, and starting with 2 terms that are so popular nowadays. Monoliths versus microservices. We have a lot of presentations in conferences, books, discussions, articles around the pros and cons of those 2 architectures. To put it simply and by using an example, my company's or your company's website in a monolithic architecture is being served by a huge monolith, a single service, which is essentially a single Git repository. In fact, talking about my company, this used to be the case until, I don't know, probably a few years ago. Now our website is served by hundreds of microservices of production code, and those services need to communicate, right? So this shift from monoliths to microservices obviously brings numerous advantages and benefits, but it also introduces huge challenges and new challenges. And one of those challenges is well illustrated in this picture, where there is a kid crying, saying that, "Dad, I lost one of my microservices. I cannot play without it." And Dad says, "Well, I told you he's not mature enough for it. We should have bought him a monolith." I hope you don't agree with that, that's not the solution to the problem. New technologies, new approaches and concepts, this is not the solution. But on the other side, we need to tackle those challenges. And one of those challenges is that your code now spreads along hundreds or even thousands of repositories. And it's hard for an IDE, it's impossible actually for an IDE nowadays to search locally or to locate source code locally because you cannot clone 1,000 or 2,000 repositories locally. Here is exactly where source code search engines come into play. To make the topic a bit more interesting to you, this is from an internal survey conducted at Google 3 years ago. The paper is really interesting. It's online, you can take a look. How many searches you think the average developer performs on an internal code search engine on a typical weekday? Do you think it's 0, 8? Is it 1 or 2? Maybe 5 to 10? Or even more than 10? Anyone? More than 10, exactly. That's actually the case. And another interesting outcome of this survey is that seniority doesn't mean less searches. In fact, it's the opposite, because when you are an experienced developer and you develop code, a lot of code during, I don't know, for how many years, you know also how and where to search. So that means more searches. Why you need a source code search engine? This is a really well-said statement from the author of Zoekt, a guy from Google who developed that code search engine, who said that software engineering is more about reading code than writing it. And part of this process is that you should find the code that you're going to read and understand. And that's quite true. That's a really well-said statement which summarizes our job as software engineers and an important aspect of software development, which is finding the code that you should read and understand. But of course, let's go through indicative examples where source code search engines can help you. They can help you understand code dependencies and avoid breaking changes or breaking your production system. This is extremely important for a company with hundreds or even thousands of different, separate repositories. This can also help you fix production issues faster by locating the root cause. For example, source code search engines can act as the bridge between Splunk or the service that indexes your logs and your Git hosting service like GitHub or Bitbucket Enterprise. So this can act as a bridge in order to locate quickly during a production issue where the issue is. Next one, find references of hosts or even code that will be deprecated. Imagine that you would like to kill a bunch of servers from your data centers. You need to make sure none of those services rely on those servers, right? That's really important. But also avoid duplicating existing code, share coding solutions and styles, and last but not least, locating security problems. You know, this is the year of data breaches and GDPR. We need to be a bit more careful about what we push to Git nowadays. Obviously, the first question that comes in mind to many people is, can't or why I can't use my Git hosting services integrated code search engine. You know, the one from GitHub, GitHub Enterprise, Bitbucket Server, I think GitLab has one. The short answer to that is, would you go to a Souvlaki shop for fish? And what's the rationale behind that question? I hope you know what souvlaki is. It's pretty much like kebab. It's the healthiest food you can have here in Greece. So what's the rationale and the meaning of that question? In the same way you might find fish at a souvlaki shop, you might find integrated code search engines in Git hosting services. The problem here is that those services don't specialize on that. It's not what they are popular for. It's just an extra feature. And to be fair, I don't think they're investing too much on that. So yes, you need a dedicated tool for that. Let's take as an example GitHub Enterprise Code Search or GitHub Search, the public one. It doesn't support partial or substring matching. This means that if I type the term day, this is not going to find Monday, where day is a substring of Monday. It removes special characters, and this makes it really hard to search for hosts, URLs, XML entries, or at code level, we have so much code that relies on special and includes special characters. So this is a huge disadvantage. Of course, you cannot do case-sensitive searches. I don't know if you have seen that already, but you cannot use any regular expressions. It just doesn't support that because it's going to add a lot of complexity to their services. And this is, again, a huge disadvantage because with regular expressions, you can search for more generic patterns. A few more reasons here. And the last one might be personal, but I feel like content fitting is not optimal in the sense that there is too much unused space in those integrated code search engines. You have headers, footers, and menus, and all those kind of things that distract you from your real purpose. Right, so we need a solution for that. We need a dedicated tool that's going to handle that for us and index and search code. We have a bunch of solutions. Probably you don't know any of those. Or who does know any of those? Right. OK. I'll go through the most important ones. There are way more than that, but I just decided to go through those because there are differences between those services. And I think it's going to be a good summary. So the first one is Searchcode Server. Searchcode.com is the public version of that service, and Searchcode Server is the enterprise version of Searchcode.com, essentially. It has been developed by Ben Boiter, and it builds on top of Lucene to index and allow you to do code searches. That's a screenshot of the service. I have indexed 3 repositories here. Pros and cons of Searchcode Server. Searchcode Server achieves consistent speed regardless of search, and it achieves that because it builds on top of Lucene, which is super fast. It is user-friendly. It allows you to do some kind of filtering, filter down to specific repositories or files or authors. I would say it's relatively easy to set up, and I really love the monitoring and admin tabs that it offers, because this can help you when maintaining and monitoring the service. And it also provides APIs. On the other side, because Searchcode Server builds on top of Lucene, it sacrifices a lot of features. And actually, it sacrifices the most important ones. You don't get full partial or substring matching. You don't fully get regular expressions. You don't get case-sensitive searches. And I would say that Searchcode Server doesn't, unfortunately, differ a lot from the integrated code search engine of GitHub. Next service which uses a different approach is Hound. We used Hound for 2 years in my company, but I'll go through that later. So Hound is an open source code search engine which uses n-grams and more specifically 3-grams for indexing and searching. For those who haven't heard about the concept of n-grams, it's a really powerful concept used, among others, for approximate matching. N-grams are essentially sequences of characters, like 3-grams are sequences of 3 characters. The core version of Hound is based on that paper from Russ Cox, where that guy is giving insights on how Google Code Search, for those who have used that service back in 2006, it has been deprecated, unfortunately, now. So how Google Code Search used to work. And the implementation is based on that. That's, again, a screenshot of that service. And then advantages and disadvantages of Hound. So Hound works in a different way because it uses n-grams. It's not like Searchcode Server. This means you get regular expressions, you get substrict and partial matching. You get, again, the same kind of filtering at file path level or repository. It has APIs, and after all, it's open source, so you can just go and use it. However, having used Hound in our company internally for 2 years, we have faced the pain of its speed, which heavily relies on your query. It can be extremely slow once you start typing complex queries. And also, it just doesn't scale. So if you are in a company that grows fast, then this is not going to be the service that's going to solve your issues. After a few hundreds of repositories, we realize that it doesn't scale anymore for us. Next service, which I would say is my favorite one, is called Zoekt or Zoekt. I don't know what's exactly the name of that. So Zoekt is, again, an open source solution which was developed internally at Google. And it uses a more sophisticated concept to index code, which is positional engrams. This is a bit of a complex concept, so I don't have the background to explain that. As I said, it was developed internally at Google, and with the purpose of overcoming the issues of Hound, the scalability and speed issues of Hound. The authors of Zoekt claim it to be 10 times faster than Hound, and I would say it's even more than that. We haven't faced any issues at all internally because we recently started using that service. Zoekt has been designed with 5 main principles in mind. The first one is coverage. And it indicates that the code that is of interest to you should be available for searching. Second one is speed. And Zoekt focuses on speed by using several sophisticated techniques like aggressive pruning in the search results page, and by also using an index which is based on positional engrams. Third one is approximate queries. And for that, Zoekt is performing substring matching in a case-insensitive way by default, but it also gives you the option to do case-sensitive searches. Fourth one is filtering, and Zoekt here is quite interesting because it allows you to filter down to specific repositories, files, or whatever, and it also allows you to filter out using the minus operator. This means that you can say, OK, I want to find something in this repository, but I want to exclude those files, for example. And finally, for ranking, Zoekt uses a concept called C tags, in specific universal C tags. It's a quite old concept used by many IDs, in order to find declarations such as method or class definitions, which are then boosted in the search ranking. That's a screenshot of Zoekt. Again, in terms of pros and cons of that service, I would say it's super fast. This is our understanding, that because it uses sophisticated concepts, it's extremely fast and extremely scalable. It provides rich searching options, way more than the ones you get from Hound, for example. And again, it's open source. Of course, there are a few disadvantages, like its UI is quite poor. It has limited monitoring, but you still get logs, which you can index and monitor. And it has no APIs or additional features. And last service for today is Sourcegraph. For those who don't know Sourcegraph, you need to have a look, because that service is going to save the future, not only of code searching, but I think of many aspects of software development as well. Sourcegraph is a company, a US startup, and their main product is their fast, full-featured code intelligence, not only code search engine, but code intelligence engine. Sourcegraph, their main product leverage is Git commands, like git grep or git diff, for non-index searches, but it uses Zoekt under the hood for index searches. And the cool thing about Sourcegraph is that it provides code intelligence features like cross-references and semantic search. And to do that, it has language models which implement the popular protocol from Microsoft, the language server protocol. One thing that you might don't know, and you should check out, especially if you are contributing to open source projects, is this extension from Sourcegraph, which adds code intelligence to files and diffs on most Git hosting services. And it does that for free for you. You don't need to do anything else, just install that, and that's it. And that's a screenshot of Sourcegraph. In terms of pros and cons, I would say Sourcegraph is awesome. It cannot be easily compared to any other services. It has excellent documentation, excellent support, numerous plugins, and the core version of that service is free. On the other side, because it's still a product, there is a company behind that. If you want to use this in an enterprise environment and get all their features, you need to pay for that, for their enterprise version. And the prices there keep changing, so that's a bit tricky. In addition to that, we have found that Sourcegraph is quite resource intensive. So if you want to install this in a big company, you might need to spend some time for that. That is a table that summarizes what I've talked about so far regarding these code search engines. As you can see here, Searchcode Server doesn't differ a lot, as I said before, from integrated code search engines. On the other hand, Hound offers the features that we want, but it doesn't really scale. It's not really fast. So better to go with Zoekt if you want something that is open source and that you can use in a big company. And finally, Sourcegraph is a fantastic solution. I couldn't find really any big disadvantages, but yeah, you need to pay for that per user. The price is per user. If you want to use it, it's enterprise version. Now, as we said at the beginning, the decision on which service to use heavily relies on your needs. So here are a few recommendations. Use Searchcode Server if you're using a Git hosting service that doesn't provide any search at all, because you will need some kind of searching. Hound, I don't think there is any reason to use Hound. Maybe if you have only a few repositories and you don't expect this number to grow fast. So use Zoekt if you're especially in big companies and you want an open source solution that's extremely scalable and fast. And finally, if you want to invest in source code searching, which I hope you do, then use Sourcegraph. Whichever service you decide to use, you will need to consider a few things. The first thing is that you should use a local SSD, especially to store the indexes. Why is that? Because those services constantly hit the disk. You are going to need an SSD here. But because SSDs, for example, instance stores with instances with instance store from AWS have ephemeral storage, it's not permanent, you're going to need something like an EBS for permanent storage in order to store your repositories or your logs, which should be stored permanently. So the architecture for us internally, it looks like that. We have an EC2 with instance store. It's actually not a big instance. It's not expensive at all. And in the instance store, we store the indexes. And we also have an EBS where we store our repositories, our cloned repositories, and their logs. Then you need to make sure that you understand the configurations of the service, whichever service you decide to use. Here, you will need to play around with the configurations, set some limits, and so on. For example, an important one is the maximum file size. Because this can break your indexer or slow down your service, you need to set such a limit. Of course, you should have logs. Most services provide logs. So monitor logs for errors, because the problem with those services is that they fail silently, which means that you're not going to have your search engine being down, but you might have your search engine not indexing things. And this is probably even worse for production issues. And finally, remember that bad documents can always slow down your service no matter how powerful your service is. So again, have logs and monitor for errors. Since last year, I would say it was hard to convince companies, even big companies, to invest on this aspect of software development. But this year, we have had a lot of different advances. The first one comes from GitHub, who are experimenting with semantic code search. And now that GitHub has been acquired by Microsoft, we expect more from them. On the side note, Microsoft offers semantic code searching for the Azure repositories. So if you're using DevOps services or TFS, you have that. The next one was announced quite recently, I think 2 months ago. Google now offers a fast code search engine for its cloud source repositories. And looking at that, it looks quite similar to what Zoekt does, so that's really cool. They have integrated this into their cloud source repositories. And finally, Sourcegraph becomes more and more popular by adding more code intelligence features, and after announcing that their main product, it is open source. So we have talked a lot about code tools that can help you when searching for code and when trying to understand code. In an attempt to tackle a very specific problem, which is that of creating and searching for API usage examples, we have built a tool internally at hotels.com, which we are planning to open source, I don't know when, maybe in the following weeks or months. That tool is called HApiDoc, and the story behind HApiDoc is that it builds on top of CLAMS, the system I mentioned in one of my first slides. So CLAMS was a framework that we developed at the University of Edinburgh. And the concept of CLAMS is that we would like to avoid the manual task of creating API usage examples ourselves. You know, the examples you get in several open source projects in GitHub under the examples directory, for example, which show you how to use this API. So what we thought was a good idea was to mine such examples from client source code. And then because probably your callers or clients are too many, you need to use some kind of clustering, to do some kind of clustering. So we applied some clustering techniques here. But we also apply a three-edit distance metric to the abstract syntax trees of the source code so that you only get one result from each cluster. And eventually, we're using a summarization algorithm in order to provide you of summaries of the snippets, because many times you don't really care about the whole snippet or the whole method. What you want really is, when you're searching for usage examples, what you want is a good summary of that snippet, right? So that's why we decided to implement a summarization algorithm here. What HApiDoc does on its side is that it uses CLAMS, which is pretty much the HApiDoc core component, but it also automates the whole architecture here, which is that it acts as an end-to-end solution to mine and search for API usage examples. As an example, we built a component to filter results, actually crawl your Git hosting services, do the filtering locally, and then calling CLAMS, which is HApiDoc core. And after that, we store those results in a MongoDB instance, and we saw those results in a neat web service. The web service itself is a quite simple one. We built it using Python's Flask framework, and it looks like that. What you can do here is to type the fully qualified method name of your method, and what you get back is results on how to use that API method, results that have been mined by the CLAMS system. But you also get some useful information here. For example, you get the project name and the repository name of your callers or clients, the method where this is being called. You also get a support, which is that thumbs up, which indicates the number of clients that are calling your API method in a similar way based on the clustering. And of course, you will get a summarized version of the snippet. This diagram might look a bit complex because it's the whole story behind CLAMS, actually, which is the work that we published and presented in academic conferences. I don't know if it makes too much sense to go through that, but I'll try to explain this from a very high-level perspective. What we have here in CLAMS is that as an input, we give the base package name of your API or library, and we also give a set of client files or callers. This is what is automated on HApiDoc after that. So this is the input of the CLAMS system. We extract what we call API call sequences, which are sequences of method calls. That's all. Then the clustering takes place by the clustering module and components. You get as an output of this the most representative sequences. The next part is to extract the abstract syntax trees and get the snippets that are associated with those top sequences. And this is passed to the snippet generator, which does the summarization. It implements the summarization algorithm. You pass your snippets from that, and you get summaries. Next component is the snippet selector, which is gonna output only a single snippet from each cluster, because you already have sequences, the most representative sequences, but obviously you need the most representative snippets. And we used a triadic distance metric for that. And finally, after that, we have the ranker, which is the final component of that system, which this is, I think, the simplest component here. It just ranks based on descending order of support. And you get a ranked list of summarized snippets as the output of the system. That's pretty much it for me. A few closing notes. First one, HApiDoc is getting open sourced, and I hope you're going to hear about that quite soon. Also, you should check out our GitHub space, hotels.com's GitHub space. We have open sourced a lot of components and projects this year. Most of them are in the big data area, but we are also involved in many fields like distributed tracing. Expedia has open sourced its HAPIDoc solution, which is an alternative to Zipkin, for example. So you can find a lot of projects there, and hopefully you're going to find even more soon. I have a repository that you could take a look at, which has material on how you can set up the services I mentioned today, the 4 code search engines, and the queries that you can do on those code search engines. If you're using any other search engines, then let us know, because we're always interested in that topic. And of course, we are hiring. Hotels.com is part of Expedia Group, which is a huge group with thousands of engineers. So if you are interested in any positions, in any roles, we have offices all over the world. Then you can either talk to me or go to our page and take a look. Thank you very much. Thanks for coming.
Thank you, Nikos. I think we've got time for questions before the last closing keynote. Oops, yeah.
Hello. A quite silly question, it might be. Instead of using this whole procedure in CLAMS, wouldn't it be possible to use the language server protocol instead and index to a known search engine, Lucene-based, Solr or Elasticsearch?
That's actually not a silly question at all. It's quite interesting. So the point here is that language service protocol was not there when we started this work. On the other side, I'm not entirely sure if you can do this with language server protocols, because you're still going to need something. I mean, language service protocols work by saying, OK, I have in that line, in that character, in that line, in that row, that character, or whatever. So I'm not entirely sure if you can mine usage examples in that way. You can do some kind of cross-references, but you need to find your clients, and then you will need the clustering in any case, right? You might avoid the very first step of HApiDoc, which is that one. You might avoid the HApiDoc downloader and the filtering step, yes, that's true. But you will still need to cluster, because most possibly, especially for open source projects, you're going to have thousands of clients. You need to cluster at this level. And you're going to need most of the components. How are you going to produce summarized snippets? For example, you need a summarization algorithm for that. You need to rank those. So yeah, I would say language server protocol could be added at the very beginning before CLAMS, if that answers your question.
Another one here.
Hello. So Happy, in what percentage can extract successfully the API of a service or system? I don't know.
Good question. So HApiDoc performs static analysis. Obviously, you're gonna miss methods here. You're gonna miss calls or whatever. On the other side, if you have a base package name, which hopefully you have, especially for production code, for example, this works by looking at your base package name and then creating sequences using abstract syntax trees. So it's still static analysis. With static analysis, you can never be sure everything's going to be mined, unless you do dynamic analysis, which is way more expensive. And unfortunately, it's a no-go for those services. But yeah, I don't know what's the percentage. What I remember when we published the paper was that for huge projects, I think we indexed a huge project for Hadoop from Apache probably, which has 500K lines of code. We got thousands of examples, and we couldn't see a lot of methods missing from there. It was just a tiny percentage, so yes.
I think we are out of time, so thank you very much once again, Nikos. It was really a great talk. Okay.